Okay. So what I had each of you do after the quiz was I had you enter or measure your forearm and your foot in centimeters, and we kind of created a little table for that. So what I'd like us to do is I'd like us to go to our stat edit feature, make sure that you cleared out numbers, and I want us to enter our forearm lengths into list 1 and our foot lengths into list 2. This is kind of like a little bit of an introduction to what we call our bivariate data unit. We have 2 different variables. Hopefully you remember from the quiz that you just took that we had 2 different variables in there, but what kind of variables were they? Categorical, or you could have said what other kind? Qualitative. Either one of those would be correct. Now we're back to quantitative or measurable data again, because we actually measured our arm, we measured our foot, but we have 2 different variables. We're going to be comparing forearm to foot length. Now what I found very interesting is that when we were kind of scrolling down towards the bottom, the data got kind of mismatched. It's going to be very important when you have bivariate data or 2 variables that they go together. One person's foot, one person's arm is one collective data gathering, okay? That they go together. So let's go ahead and enter what we have here. I'll pause the recording while I enter those numbers, and we'll come back in just a second, okay? So it appears as though I've entered the data, okay? Hopefully you've got your data in list 1 and list 2. And I have 2 different quantitative or measurable variables. I'm talking about arm length, forearm length, and foot length. And I picked those because they're easy to measure, and there actually is what we call a strong correlation, and we'll talk about what that means eventually, because it's very specific in this class, and you have to use that word in only certain circumstances. But correlation, this has a strong correlation between these 2 things. Height and feet size, foot size is also something that is highly correlated. Usually people with big feet have long arms. And often it's actually, they're supposed to be almost identical. Have you ever heard of that before? Where you can put your foot, like pretend like you're doing yoga, and it should be like exactly the same size. Anywho, we can obviously, in some cases that's true. Some of you are going through growth spurts or not so growth spurts or can't measure. It's one of the 2. Anywho, all right. What I'd like us to do is I'd like us to graph this, okay? So whenever we were talking about graphs before, okay, we graphed box plots, did we not? We've graphed histograms. We've graphed bar charts and pie graphs. But when we talk about bivariate data, it's a completely different type of graph altogether. Anybody know what it's called? Scatter plot, gives an S, okay? And we're actually going to do something called residual plots eventually too. So bivariate data has 2 different kinds of plots that are associated with it. We're going to start today with just the basic scatter plot. So what I want us to do is I want us to turn our stat plot on. Maybe. There we go. We'll turn it on. And the scatter plot is the correct option. So the type that's listed here is the type you should have. You should also probably make sure that there's nothing in your y equals. There's no equations that are in there. It's just plain. We just want to graph the scatter plot. We did put our list 1 and list 2 is where we put our lengths of our forearms and our feet. So that is correct as well. And then if I just make sure there's nothing in my y equals, my plot 1 is darkened, what's the quickest way to get a nice picture? Do you remember? Zoom 9, zoom stat. So we're going to zoom 9, zoom stat, and we should get a nice picture, okay? So this is called a scatter plot, and it's a scatter plot of our class's data, okay? Did you get the same kind of picture on your calculators, hopefully? Okay. Anybody know where they lie in that particular line or that particular set of points? You never know. Might be a measuring issue, right? When we talk about this kind of data, we talk about trends, okay? And we have to discuss about, is there a trend between, or is there an association between feet size and forearm size? What do you think? Do you think that they are associated? And specifically in statistics, we're going to only talk to it being linearly associated. We're going to actually end up transforming all different kinds of associations back to linear. So in statistics, we only worry about things being linearly associated. Could you draw a line that would best fit that data? Do you remember how to do it from Algebra 2 in the calculator? With the calculator. I want the exact equation. Okay? Okay, so here's what, if you don't remember, you need to write this part down. Okay? Because this is something I fully expect us to be able to do. On the calculator, in order to find the line of best fit, you're going to go to Stat. I'll write it down over here on the side. We're going to go to Stat, over to Calc. And there's a couple of different options we can choose from. Okay? So Stat, over to Calc, and then we have all these different lines. In statistics, if you actually look at your formula sheet that I gave you, the line of best fit is actually written in this way. I'll write it here. This is on your formula sheet. That is the line of best fit. Okay? Notice a couple of things. Notice that when we're talking about a regression equation, why did it do that? That was really weird. We're talking about a regression equation. It doesn't want to do that. It won't. Okay, whatever. I'm talking about that little hat there. Okay, that little hat does mean that this has been a regression equation. Anytime that you're doing a regression, I am requiring you to use that notation. So if I ever ask you for what is the equation of the line of best fit, you must put a hat over your y. And specifically, we're going to actually write it with in terms of the variable. So I'll explain what that means in a minute. But we're going to write words in for x and y, not just write the variables. What is usually the letter or the number that's with the x when we're talking about, think about algebra for a minute. The slope. So in statistical terms, the B1 is what we call the slope. Okay? So this is going to be the slope. And then the B2, I'm sorry, the B1, the B0, this guy right here, very strange it was not doing that. What does that represent? The y-intercept. You're just thinking about back from Algebra 1, do we know slope and y-intercept? And just it's a different notation at the AP Stat level, that's all. Not only are you using B0, by the way, that's how it's read, that B sub 0 is just read B0. B0 and B1, what else do you notice about the order of the equation? It's kind of backwards. Aren't we so used to doing y equals mx plus b, right? So that's the kind of a different thing that we do in statistics. And I'm not really sure why, quite frankly. I just know that we always write, this is the formula that is used. It's the same formula you're used to, it's just a little out of order, that's all, okay? So we know what the slope is and we know what the y-intercept is. So let's look at our options on our calculator. Pay attention to the form that it's used. If I use this option, lin-reg, okay, which is fine to use, what do you notice about the order of the slope and the y-intercept? Okay, so that's what we're used to using, right? If you can still use it as long as you remember to flip the order, okay? Or you can just scroll down and actually option 8 is the correct order. Does that make sense? So it doesn't matter which one you use, just pay attention to the number with the x as your slope, period. I'm going to go ahead and use option 8. We did put our list 1 as our x's, that was our forearm length. Our foot length was in list 2. Everything else should be blank, and we'll just calculate that information. And it gives us some information. Now, some of you might have something else on your calculators. Anybody have the R by any chance? Nobody. Darn. Okay. Well, we need to have the R on. We need to turn it on. Okay. So let's write the equation first. So stat calc, and then it was lin-reg. I believe it was option, was it 8 or 9? 8. Okay, I'm just going to write it over here as our choice, so we have those calculator steps over here. And that gives us what we call the line of best fit. Now, it is missing something called the correlation, and I will add that in a couple of minutes. But I'd like us to plug this equation into the calculator first and graph it. Okay? So there is a way to not round it at all and plug it into the calculator. So if you wanted to round it, you could say y equals 6.72 plus 0.764x. That would be rounded. Wouldn't you agree? So I'm going to write that over here onto the side so we can kind of recognize what it would be rounded. Let me kind of bring it down here so I can see. But our equation is y hat equals 6.72 plus 0.764x. Would you agree with that? Just rounding, okay? Just taking the numbers and plugging it into the equation. I would prefer it if we didn't round it in the calculator. So if we went to y equals and we wanted to graph the line, I'd prefer it if we didn't round. I'm going to show you how to do that.
Well, we're going to get the same numbers you got.
It's do you? Did I enter? I must have entered something wrong. All right, that's entirely possible. Let me just double check. Double check that I have the numbers entered correctly. Did you, hang on, one other thing. Did you guys make sure, did you have 21 numbers listed in your calculator? 21? Did anyone else get the same exact numbers I did or no? You, Lindsay, you got, a couple of you did.
Oh, I didn't see those last two.
Yeah. So,
yeah, that makes sense.
all right. Let's go back and make sure. So what I'll do here is I'll pause the recording because it looks to me like some of us might have entered it incorrectly, and it might just be me. I don't know. Let's double check ourselves. So I'm going to pause this and let's just make sure we have it entered right. Okay, so it looks like we got ourselves figured out. Let's go back and recalculate. So we'll stat calc. I'm going to go down to option 9 again. 8. I love it, y'all catching me. That's good. And we're going to calculate. All right, so it looks to me like our equation's a little bit different. So I have, what, 7.3. Let's move this up a little higher. So let's change it. So we'll change this equation here to be 7.31 plus 0.746x. And don't forget your y hat, because it is a regression, okay? It is a line of best fit, so that notation's important. Is that the one you guys got now? Okay, all right. So one other thing I'd like us to do, and I'll show you how to put it without rounding into the calculator, because I think that's going to be important. I'd like us to be able to write the equation in context. Okay, so what does that mean? What two variables did I use? Forearm and foot length, okay? And which one was our first variable? This one was the arm, and this one was the foot. So if I'm thinking about x and y, okay, which one would the arm be? Because think about x, y coordinates, right? So wouldn't this be x comma y? We're talking about a point on a point, right? So the x, I'm going to replace the word x with arm length. And I'm going to put the numbers back in. And I'm going to replace the y with foot length. And what am I going to put over the words foot length? A little hat. So this is actually, in its entirety, what I would expect you to be able to write notationally and contextually, what I'm looking for when I ask you for the line of best fit. AP is very, very particular when it comes to their notation and when it comes to their context. They really, really, really want you to put everything in context. And so whenever you're writing the equation, you need to write the variables in it, okay, with words. Yes, ma'am. It is called a hat. It's just called a hat, believe it or not. Yeah. It is weird. It's not like an accent aigu or anything like that. It's just a hat, okay? And it's actually red foot length hat. It's weird, right? Yeah, sorry. It's a good question, though. I'll look it up, but I've never heard it read any other way. All right, so we know how to, are we okay? Any questions or concerns about that part? Now, how do I put it into the calculator without rounding, just so I can see a picture of this line through those data points without actually doing anything awful? So if you go to your y equals, like I was going to plug it in from the rounded part, okay? Now this will only work after you've calculated the regression itself, because that equation is actually stored in the calculator's memory. So if you actually go to vars, so find your vars key. It's over here on the right by the clear. and you scroll down to statistics. Now, where was I when I started this? I was in the y equals, wasn't I? Because I'm telling the calculator to put that equation in the y equals. If you hit statistics, it's going to say, what? Go ahead and go over to equation, and you're going to just hit enter for the regression equation and type enter. It will actually put the most recently calculated regression equation into the y equals for you. So I'll write those things over here to the side. It's going to be, so the stat calc lin reg is to find the regression, or to find y hat, okay? To enter it into y equals, or to, I will say to graph. I guess that's a better way to say it. To graph our equation, these are the calculator keystrokes. So to graph it, what you're going to do is you're going to go to vars, statistics, equation, and then it's regression equation. And you're just going to hit enter. But you have to start in the y equals button to put it there. So when I hit enter here, notice it puts this whole big nasty thing in. All it is the regression equation. If you kind of scroll back, you will see it's just unrounded. That's all. Yes? You have a question?
If you go to stat, when you go to the regression to like put it in,
Mm-hmm.
like you can put in your x list and your y list, and you can store the regression.
You can't, okay. So let me do that again. So if I go to, so anyway, let's just graph it. Let me show you what it looks like. Here's the line of best fit. What Devin's saying is that you could have done that as well by just going to stat calc, and then you go down to your option 8. And he's saying that you can store your regression equation somewhere if you want. Okay, that's perfectly okay. Where would you store it? Does it?
Bars, y bars.
Yeah, you just don't have to even do that. It'll just automatically store it there for you. So I've never actually used that. I guess maybe if you do more than one, yeah, that would probably be a good use of that function. But the most recently calculated one is the one it always uses. But if you do more than one, for all means, you can do that. All right, so here's my graph. Does it look like it fits the data fairly well? Okay. I want us to make sure that we kind of keep this data for a little bit, because I want to use it next time, because it's really an interesting group. You never know what you're going to get because you actually measured it. This is something that I couldn't really plan for what it would look like. But let's talk about some trends, okay, or some things that you notice about the graph. What are some things that you do notice? Okay, there's quite a bit of data, I wouldn't say most, but definitely quite a bit of data that where it's below the line, okay? Anything else? And that's going to come into play when we talk about residuals. What else do you notice?
It varies directly.
Okay, varies directly, possibly. It would vary directly if it actually went through the origin. Yeah, so it doesn't vary directly because direct variation actually has a y-intercept of 0, and this definitely has a y-intercept.
Very few points of the fair actually fall on the line.
Okay, and that's something very unique, that there's very few points that actually fall on the line of best fit, and I'm not sure that really matters, because really what a line of best fit is something that fits the data, and it doesn't necessarily mean that they should be on there. Some should be above, some should be below. I think what Temerson was saying is that, and I wish I could circle on here, I don't think it's going to let me, but this, oh it does, look at that, how fun. That this is what he's talking about. All this group of points are below the line, and that's kind of unusual. And I'm telling you that that is okay because we have some really points that are really up and far away from that line, aren't there? The ones that are above it are really far above it. Would you agree with that? And so when we talk about the line of best fit, what it actually is doing, and it's a calculation, is it's minimizing all of those vertical distances. So it's finding the line that best fits the data by, I'm going to say it one more time, this might be something you write down because I'm going to probably ask it again, is it's actually minimizing all of these vertical distances. If you notice on the bottom, aren't they kind of smaller than the ones on the top? They're smaller distances, and the ones on the top are a little bit bigger. So even though Temerson suggested that all of these points below, there's more points below, well, they kind of even out in a way. Okay, and actually, these are called residuals, these vertical distances. We'll define that officially next class. but they should always be close to 0 when you add them all together. Because that is the definition of the line of best fit. So again, what does the line of best fit do? Minimizes the distances. And it's not going to let me, there it goes, okay. Minimizes those vertical distance from the actual points to the line of best fit. Okay, that's what it's doing. Now, something else that we're going to come back to this calculator thing in just a second, but I want to discuss something called correlation, if we could, for just a minute, because that's something your calculator should have on it, and it doesn't look like a lot of us did. Okay? Can we look at these particular scatter diagrams, scatter plots, and let's decide the type of relationship that they have. Now, again, what are we worried about? We're worried about the linear relationship, okay? So, this particular graph over here on the top left, it's nonlinear, would you agree? Okay, so in statistics, we really say it might have an association, but not a linear association. It's actually quadratic, okay? Possibly, it could be something else, but so we say it's nonlinear. Would you agree that this one's linear? Okay, what kind of a correlation, because you know what that word should mean, does the second graph have? Let's actually number them. Oh, sorry, I wrote 2. I'm not sure what I'm doing. 0, 1, 2, 3. Let's number them 1, 2, 3. So what kind of correlation does graph 2 have? And what I mean by that, positive or negative, is really all I'm asking for. It's going to have a negative correlation. Okay. And how about this one over here in number 3? Okay, it's going to have a positive association, which means that its correlation is also positive. And again, the ones down here, this one possibly could have a positive relationship. You can kind of imagine that, but it actually is pretty severe. It looks cubic to me almost, don't you think? But I would agree it probably does have some kind of positive association. And then down here, this one has no relation at all. What do you think the correlation would be for number 1? Now, correlation only measures the linear strength. Linear strength. So what would the correlation be here? None, close to 0. Okay? And how about down here? Also close to 0. Okay? Now, I kind of agree with Zachary in this left one here. I think it's going to have some kind of positive correlation, but I do think that it's strong, more cubic than it is linear. But I agree with you. I do think it's a positive association. So, don't ever write this down. Please, God, no. Okay? Don't do it. Okay, I'm going to highlight some things that I want you to pay attention to. Okay? Again, you can print these off, and that's fantastic. I'm not even sure why I wrote all this down. But let's talk about what's important to get out of it. Okay? Pearson's correlation coefficient, okay, I'm just going to write Pearson's R, okay, is what the book calls it. Pearson's R. It's called that because Mr. Pearson, not the same testing company people, okay, but Mr. Pearson developed this number. And if you're interested in the formula, you'll read about it tonight. It's kind of crazy. If you want to calculate that letter by yourself, that variable by yourself, have at it. It's really something I'm never, ever going to ask you to do. It's on your formula sheet, actually, if you're interested in. It's R equals, it's right here. You can see this formula. That is the formula to calculate the correlation. It tells you how the variables are related, or how strongly they are related. I will never ask you to calculate it by hand, okay, ever. It's not necessary. What I am going to ask you to do is to interpret it, okay? Your calculator will find it for you. Things that are important. Correlation is always between -1 and 1. It can equal -1, and it can equal +1. You should remember that correlation, when we talk about if it's a strong correlation, what is it close to? 1 or -1. What's a weak correlation close to? 0. So the more middle it is, the weaker the relationship, the weaker the linear relationship, and the more towards the 1 and the -1, the stronger it is. Here's something else that's important. Correlation is unitless. You're not going to say correlation has a correlation of 0.2 centimeters. That makes no sense. Okay? Correlation is unitless. It simply is a measure of strength between the two variables. That's all it is. Okay? It plays no role in the interpretation of anything in terms of the variables, just how well they are related to each other. So let's turn it on our calculators. Okay? Let's see if we can find it. Do you remember how to do that? Okay? So let's see if I can turn it on. There we go. Okay. I'm going to go ahead and quit out of here. And I don't really know anywhere else other than the catalog. If anyone else knows a shortcut, I'd be thrilled to learn where it is. But you have to turn your diagnostics on. Is it mode? Okay. Let's see where. Oh, mode. And then where do I go? Is it down there? Oh, look at that. Stat diagnostics on. Check you out. Awesome. Okay. Has that always been there, or is that just with the newest update? Okay, cool. So go to mode and scroll down. We're going to turn our diagnostics on. I've always gone to the catalog and scrolled down to diagnostics on and off, but you want to turn them on. Okay? So mode, stat diagnostics on. That will allow the correlation to show up. So we have to go back now and recalculate our line of best fit. So again, using these blue things I've written over here, these blue directions. Once the diagnostics are on, stat, calc, linreg. And then R should show up. R squared is something different. We are going to talk about R squared, but not today. It is something totally different. Okay? So again, stat, calc, option 8. And R should now show up. We have a correlation of 0.677. Is that strong? No. It is not very strong. In order to be a strong correlation, we need to be upwards of 0.8, 0.9, 0.95. Or on the other end, negative 0.8, negative 0.9, negative 0.95. I don't really think these are really strongly associated at all. Okay? That's just the definition. In order to be a strong correlation, you have to be either close to 1 or close to negative 1. 0.67 is not really close to 1. It's kind of in the middle. We might say moderately associated, but I would definitely not say they are definitely associated. Okay? So we have to kind of use these vague terms in statistics. So I think that moderately associated would be okay here. Okay? Definitely not strongly, though. Wouldn't you agree? Okay. So I just wanted to make sure that we remembered how to use our calculator to graph a scatter plot. You are going to be assigned officially on Wednesday your first investigative task. Okay, and we're going to have several of these throughout the year. And I give you about 2 to 3 class periods to get it done. It'll be due before your bivariate test. And it's going to look, you're going to look at 4 different data sets, and you're going to graph not only scatter plots for each, you're going to find equations of regression for each, you're going to look at residual plots, which we'll do next class. It's kind of a lengthy project. So just kind of be prepared for that. It's coming. It'll be in the future. Your homework is going to be to read chapter, I believe it's 7. Okay, this is in the intro to this. So your homework is going to be to read chapter 7 and to do the just checking. Now you know where those answers are. So what does that mean I'm going to be looking for? Work. Okay. Okay? And that's really, you'll get your assigned project next time. It's a good idea to bring some graph paper for this unit. So if you have graph paper, that would be good to have for Wednesday. Okay?